The idea of a creature like the xenomorph, sleek, biomechanical, hyper-aggressive, and perfectly evolved to kill, has haunted science fiction fans since Alien first hit screens in 1979. But could such a nightmare exist in reality? To answer that, we must examine the biology, ecology, and evolutionary plausibility of the xenomorph, breaking down its traits to see if nature could produce something even remotely similar. The xenomorph's life cycle is its most infamous feature. It begins with an egg, which releases a facehugger, a spider-like parasite that attaches to a host's face, implants an embryo, and dies. The embryo, a chestburster, gestates rapidly before violently erupting from the host's chest. Within hours, it molts into an adult, a deadly predator with acidic blood, a chitinous exoskeleton, and a secondary mouth for maximum lethality. Could such a parasitic reproductive strategy exist in nature? Surprisingly, yes, though not to this extreme. Many parasites manipulate their hosts to ensure their survival. The Ophiocordyceps fungus, for example, infects ants, hijacking their nervous systems and forcing them to climb to an optimal spot for fungal growth before erupting from their bodies. Similarly, parasitic wasps like the glyptopantles lay eggs inside caterpillars. The larvae eat their way out, much like a chestburster. However, the xenomorph's rapid growth and extreme violence are beyond anything in nature. Most parasites don't kill their hosts so quickly. Evolution favors those that keep hosts alive long enough to spread offspring. The xenomorph's life cycle seems designed purely for terror rather than ecological efficiency. One of the xenomorph's most terrifying traits is its acidic blood, capable of melting through metal. In nature, some creatures have corrosive defenses. Bombardier beetles spray boiling chemicals, and the terroir lionfish delivers venomous spines. But blood that dissolves anything it touches? Unlikely. Acid requires energy to produce, and a creature with such blood would need extreme adaptations to prevent self-harm. The xenomorph's exoskeleton might protect it, but even then, any wound would be catastrophic, not just for the attacker, but for the xenomorph itself, as its own blood would eat through its body. Evolution would likely favor less self-destructive defenses. Xenomorphs are often described as perfect organisms, with no wasted energy, no fear, and only pure predatory instinct. Their biomechanical appearance suggests an unnatural origin, possibly engineered by the engineers in alien lore. But could such a creature evolve naturally? In reality, evolution is messy. Traits develop through random mutations and selective pressures, not for perfection, but for good enough. The xenomorph's sleek, armored body, retractable inner jaws, and whip-like tail seem too specialized to arise naturally. Even apex predators like big cats or sharks have vulnerabilities. The xenomorph appears unstoppable, which is unrealistic in a balanced ecosystem. Xenomorphs often operate in hives, with a queen directing drones and warriors. This eusocial structure resembles ants or bees, but with a horrifying twist. The queen births countless offspring, and the drones are expendable killing machines.